Hello friends, I am Rahul Gawande. Welcome to our channel. Dear friends, in this video we are going to study practice set 3.1 of chapter 3 polynomials of maths 1 of standard 9. First question of practice set 3.1 is state whether the given algebraic expressions are polynomials. Justify means reason we have to write. Let's see example number 1. First, y plus 1 upon y. Now we have to state whether this expression is polynomial or not. Now condition for the polynomial is that all the indices or all the powers should be whole numbers. If all the powers are whole numbers, then that is the polynomial, otherwise not. Now here let's see, first expression is given y plus 1 upon y. Here index of this y is 1. This is whole number, it is right. But what about this second y is in the denominator, and when we write this y or y in the denominator, in numerator its index will change, its power becomes negative. Now how to write this? Y plus, now this 1 upon y is equal to y plus y raised to minus 1. Now this y becomes minus 1 here. Here index is 1, but when we write this denominator in the numerator, its index or its power becomes opposite. Now here is plus 1, but it becomes now minus 1. And now according to the condition, minus 1 is not whole number, and that's why this expression is not polynomial. Then what is the justification? What is the reason? Reason is that the power minus 1 is not whole number. This is the reason. Hence y plus 1 upon y, that is y plus y raised to minus 1, is not polynomial, and this is the answer. In first line this is reason, justification, here answer. Now second algebraic expression is 2 minus 5 square root of x. 2 minus 5 square root of x, we can write this as, now here you see 2 minus 5 as it is, square root of x we can write in the form of index as x raised to 1 upon 2. Square root is written as index 1 upon 2. And now again reason, we got the power 1 upon 2. Is it whole number? No, is not whole number, and hence then what is the answer? Is it polynomial? Then no. Hence 2 minus 5 square root of x, that is 2 minus 5 x raised to 1 upon 2, is not polynomial. This is justification. Third algebraic expression is x square plus 7x plus 9. Now here 2 is the whole number, here is 1 is also whole number, and here index of this, power of this is 0, 0 is also whole number. Therefore here we can write now the powers 2, 1 and 0 of variable x are whole numbers. Hence x square plus 7x plus 9 is a polynomial. Third algebraic expression, 2m raised to minus 2 plus 7m minus 5. The power minus 2 is not whole number. Hence 2m raised to minus 2 plus 7m minus 5 is not polynomial. If the algebraic expression is 10, only the number 10 is given, and this is constant polynomial. Constant. The power of constant polynomial is always 0. Though we are writing here 10, if you want to write in the form of x variable, then that is written as x raised to 0. 10 multiplied by x raised to 0 means here variable is not given, but then also there is x raised to 0 or any variable with power 0, because according to the rule of index, value of x raised to 0 is 1, means 10 multiplied by 1 value we get 10. This 10 is like that. Then what is power here? 0. And is it whole? Then yes. 10 is constant polynomial the power 0, now in bracket you can write, is a whole number. Hence 10 is a polynomial. We have written already here constant polynomial, but then again answer of that. Now question number 2 from practice set 3.1 is, write the coefficient of m cube in each of the given polynomial. We have to write coefficient. Coefficient of m cube means the number multiplied to m cube. Whatever number is multiplied to m cube, that is the coefficient of m cube. Let's see first example. First polynomial is m cube. Now here multiplied to m cube means here number is not given, there is 1. Therefore what is coefficient here now? Coefficient of m cube is 1. Answer is in one line only. Second polynomial is minus 3 upon 2 plus m plus square root of 3 m cube. Now first see where is m cube. M cube is here, and which number is multiplied to this? Then this one, square root of 3. Then this is the coefficient. The coefficient of m cube is square root of 3. Third polynomial is minus 2 upon 3 m cube minus 5 m square plus 7m minus 1. First see where is m cube. M cube is here, and which number is multiplied to m cube? Then this fraction. Then this is the coefficient. The coefficient of m cube is minus 2 upon 3. Coefficient may be any number. There is no condition for coefficient. Then minus 2 upon 3 is coefficient of m cube here. Question number 3 of practice set 3.1. Write the polynomial in x using the given information. We have to use variable x. First, monomial with degree 7. Monomial means only single term, one term, and which variable we have to use? X. Then x raised to highest index we want 7. Degree means highest index, highest power, we want 7. Then x raised to 7. And we want monomial, that's why we cannot add here any other term. If we add, then that will not be monomial. Therefore x raised to 7 is the monomial. And if you want to write here coefficient, you can write, no problem. 2 3 4 minus 2 minus 3 minus 4, fraction also, that is not the problem for coefficient. But x raised to 7 compulsory we want there. If you want to keep only x raised to 7, then also write. If you want to write any coefficient here, then also correct, but single, that is monomial. Second is binomial with degree 35. Binomial means two terms, there should be two terms. X degree 35, degree 35 means highest power 35, x raised to 35 compulsory, and with that you can change here any, from 34 to constant number you can write any here, and coefficient also you can change if you want. Now here if you want, you can change, that is open-ended example, you can change any. If I want to write, I can write anything here, x raised to 35 plus x, I want to write. If you want to change, you can, but x raised to 35, this term should be there, that is open-ended example. What is the third? Trinomial with degree 8, means x raised to 8 compulsory we want, x raised to 8, and other terms you can change, but how many? 3. I want to write 2x plus 5. See how many terms? 1 2 3, 3 terms. What is highest index? 8, means degree 8, finish. These terms you can change. Here coefficient you can change, but which term must be there? X raised to 8, and these are the polynomials in X. Question number 4 of practice set 3.1 is write the degree of given polynomials. For that question I prepared a table, and here in first column I wrote polynomials, and in second we will write degree. What is degree? Degree is the highest power, highest index is called degree. And one more point to remember, that if that is constant number, means constant polynomial, degree of that is 0, highest index is 0 of constant polynomial. Okay, now let's see. Square root of 5 is here variable? No, means this is constant polynomial, and as I told you that highest index or degree of constant polynomial is 0, therefore here answer is 0, degree of this is 0. X raised to 0, already it is given there, index 0, and single term monomial, here also degree 0. X square, single term means monomial, highest index 2, that's why degree is also 2. Fourth, square root of 2 m raised to 10 minus 7. Now here are two terms, this is binomial, but what is highest index? 10, therefore degree is 10. 2p minus square root of 7, two terms, binomial, here p, its index is 1, and this is constant, its index is 0, 0 1, what is highest index? 1, therefore degree is 1. 7y minus y cube plus y raised to 5, here is 1 3 5, what is highest index? 5, therefore degree is 5. These are polynomials in one variable. If polynomial is more than variable, then here more than one variable. If polynomial is in more than one variable, then we have to do sum of their powers, and which sum is highest, that is the degree. Let's see. X, Y, Z, index here 1, here 1, here 1. What is sum of these powers? 3. Here is 3. X, Y, here 1, here 1. 1 plus 1, 2. Its sum addition is 2, and here is only 1. Means here 1, here sum is 2, and here sum is 3. Then what is highest in that? 3. Therefore degree is 3 here now. Sum of these numbers. Highest sum is 3, that's why degree 3. Last example, m cube n raised to 7. What is sum here? 3 plus 7, 10. Here 10 is the sum. What is sum here? Here is 1. 5 plus 1, 6. Here 1, 1. 1 plus 1, 2. 2, 6, 10. What is highest sum? 10. Therefore, degree of this is 10. In this way, we can write the degree of both type of polynomials in one variable and more than one variable. Question number 4 is classify the following polynomials as linear, quadratic and cubic polynomial. These are the types of polynomials based on their degree. If degree is 1, this is linear. If degree is 2, means highest index is 2, quadratic, and if degree is 3, then that is cubic. Just we have to write the type. This is very easy example. Let's see. 2x square plus 3x plus 1. What is degree? 2. Degree 2 means quadratic. Therefore, here type of that is quadratic polynomial. In this way, we have to write answer. 5p. What is index here? 1. Highest index 1 means degree 1. Degree 1 linear. Linear polynomial. Linear polynomial. Degree 1. Third expression, square root of 2y raised to 1 minus 1 upon 2. 1 is the highest index means degree 1. Again linear. M cube plus 7m square plus 5 upon 2m minus square root of 7. What is highest index? 3. Means degree is 3. If degree 3, this is cubic. Fifth, a square, single term, monomial. But what is highest index? Degree is 2. Degree 2 means quadratic. Last example, 3r square, single term, monomial. But what is highest index? Degree 2. Degree 2, quadratic. Same. In this way, we can classify given polynomials in these types based on degree.